Hey, what's up, guys? This is Chung here. So today, let's take a look at one interesting Codeforces problem. This one, Orac and medians. So basically, you're given like a sequence of positive integers, right? A1 to an here, and in one operations, so the Orac can choose uh, an, any arbitrary sequence, subsequent range, L to right of the sequence, and replace all the values within this range to the value of the median of this R here, of this range here. So what's the median of this? So the median of a sequence is the length of the S plus 1 divided by 2 smallest number for in the range here, right? So for example, the median of this 1, 4, 4, 6, 5 is 4. So the reason being is that, if we sort these things, right, we have 1, 4, 4, 5, 6, right? And the length of this one is 5, right? So if we use this kind of formula, we have 5 plus 1 divided by 2, which is 3, right? Basically, that's the third smallest number in this range, which is 4 in this case. We have 1, 2, and 3. That's why the answer is 4, right? And this is like the basically the odd number case here. For the even case number, right? So for even number, we have 1, 5, 7, 8, right? So, and then we have this 4 plus 1 divided by 2, which is 2, right? So it's going to be the what? The smaller index here, which is 5 here, right? So basically the medium is like if it's odd, right, we of course will get the middle one. If it's even, right, we'll get the ones on the left side. Of course, after sorting the entire string here, the entire sequence here. Okay, and okay, and then our purpose is that we can do any number of times of these operations, and our final goal is that we want to change all the numbers into this sequence into the target k here. Okay, and so our task is just need to return either no, yes or no. Basically, if it's possible, then we return yes. Otherwise, we return no. Right. So here we have some examples here, and the input, right? So we need to answer like t test cases, and then the first, and then for each test case, the first one is the number of the number of the sequence, and then the second one is the is the what the k, right? Okay. So for example, for the first example, we have 1, 5, 2, 6, 1, right? So obviously this one, the answer is no, because first, I think it's obvious that if the k doesn't even exist in this sequence here, we'll definitely return no, right? Because we can only set this range into a number that appears in this subsequence, right? Subarray. If the k never appears, then of course that's going to be no. That's why the first one is no here. And then for the second one, we have 3 and 2, right? So the target is 2. And the answer is yes, because we can, for this one, since we have 1, 2, and 3, right? So, and the k is equal to 2. So for this one, we can simply do this 2 and 3 here, right? So for 2 and 3, since the by applying that formula here, this one will becomes to 1, 2, 2, right? And then if we apply another one on this entire range here, right? So we have 2, 2, 2, right? So that's why this one is yes. And then for this one, we have 3, 1. Okay, I think we have another one here. So this one is like the 1, 6. Yeah, of course. This one is like obvious because we only have one numbers. And then for this one, we have 3, 1, 2, 3, right? And the target is also 3. And and the k is 3 in this case. So this one is no, because there's no way we can change all numbers to 3, because basically there's no there's no way we can do it, because no matter how we choose the range here, if we change this 2 3 here, we only get 2, right, instead of 3 here, because the median of this one is here. And then with that, even though we have another 3 here, if we do this one, because remember, it's going to be assorted, right? So for this one, we'll have 1 here, because 1 is smaller than 3, right? So that's why we cannot get that. And for this one, for the last one, the answer is 3, which is also fine, because this one, I think this is a good example here. So we have 1 2 3 4 5 6 7 8 9 10 here, So for this one, k is equal to 3, right? So this, and actually it works. So how it works, because actually, in the note here, it gives you like another example, which is the 1 6, 1 to 6, because from 1 to 6 here, we have the median is 3, right? So it's saying that we can change all this 1 to 3, and then we do another one from 2 to 10, right? This is also, then for this one, the median is also 3 here. That's why we can change everything into 3. Okay, so that's how it explained for the second one, for the last example. Yep. So basically, that's the description for this problem. So to solve this problem, it requires some observations, right? So what's going to be the observation? I think we have already found one, which is the k has to exist in this sequence first, right? But let's assume this k exists in somewhere in the sequence, and what's going to be the next conditions to make so that we can have a yes here. I think the first one is that, let's say we have a k here, if we have a k, and then we have another number here. Let's say we have a k uh, k and l. Okay, so I think the first scenario is that, as long as there's like a number next to k which is greater, l is greater than greater than k, then we can be sure, right? If they are next to each other, right, then we know that, the answer is yes. And why is that? Because with this k and l, where l is either is greater or equal than to k, so this thing can be changed to k and k, right? As long as we have this one, actually we can extend this k to the entire array. And why is that, right? So let's say we have a x, 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 and we have a k and a k somewhere, right? And then we have some x, x, x. Because for this one, as you guys can see, right, we can always try to extend this one, because if we do a like operation for this, which like if we extend on the left or right, so this one we have what? We have x, k, k. So it doesn't really matter if the x is either smaller or greater than k. The medium is always k, right? So which means that if we do like an operation for this one, we can change this one to k, right? And then we can do this one again, right? We can either do it for this k, or we can do it for the entire 4 numbers here. So which means this one will become to k again, and then we can extend to this one, right? This one will also become to k, so on and so forth. And eventually we can just simply make everything into k. So that's going to be the first case here, right? And then this, but that's gonna be the first case. So how about a second scenario? So second scenario is that, the next one is not is smaller than k basically. And then what's gonna be the other conditions that we can return yes? That will be, you know, that will be the if within three numbers here, three consecutive numbers, if two of them, if at least two of them is greater, is either equal or greater than k, then we can also return true. And why is that? Let's say we have examples here. I'm going to draw you an example here. So let's say we have this one. Assuming we have this number, we have 2, 1, 1, 1, 1. We have few ones, and we have 5, 6, 0, and we have 0, 1, 1, 1, 1, something like this. And the k is equal to 2, right? So now we have first we know, okay, so the k appears in this array here. But and what's going to be the result for this one? So for this one, the answer is yes. And why is that? Okay. So, first we cannot do the operations on any of this on any of the numbers which is smaller than 2, because in that case this 2 will be replaced by 1 in this case, right? But keep look at this part. So we have 5, 0, and 6. If we do like an operation on this part, so what will we get? We'll get the median of this range, which is what? Which is 5, right? So which means that this one will become to 5, 5, and 5, right? And with this 5, 5, 5, what we can do here, we can extend this 5, 5, 5, right? Just like what we have, we can extend this 5, 5, 5 into all the directions, right? Because like I said, since we have this kind of 5, 5, they are the same, right? We can just extend this one to left and to right. So we have this one will become to 5. This one will also become to 5, right? Similarly, like because if we do 1, 5, 5, the medium is 5. That's why we can keep extending to on both directions. So which means that on the right side, this will also be 5, 5, 5, 5, right? And here will also be 5, 5, and 5. But at this moment, right, see that, whenever we have reached this 2 here, that's when we will stop. And from here onward, right? So what's gonna do? What are we going to do? We're going to do an operation on this part now, because now the next number of 2 is either equal or greater than 2. And then it goes back to the first scenario, right? Which is the k and l scenario, right? Where the k, uh, where the L is greater than K, right? Right. So in this case, we can start doing this operation on 2 and 5, which will become to 2 and 2, right? And then we can start extending this 2 and 2 right now, right? And this one will become to 2 here, right? Because 2 to 5 is 2, and then again we have 2, 2, 2, 2, right? So eventually this thing will become to 2, and that's why we get yes here. Okay. So now, we have find all the scenarios that can give us a yes. So what's going to be, so the first one, K need to exist, right? So that's the first one. The second one is that, second case is what? We have K and L case, right? Where L is greater than K. And the third one is that, any consecutive, right? Any 3 consecutive numbers, at least 2 are greater are either greater or either equal or greater than k, right? So actually this is 2 or 3, right? So 2 and 3 they're like or, and 1 is and, right? So basically 1 plus 2 or 3, that's going to be the condition for that. Okay, and actually, if you look at this one even closer, actually 2 can be represented by 3. So which means that we don't have to check this one we don't have to check the second condition separately. We can only check the third condition, right? Because because if we have like k and l where l is greater than k, right, and then it will also satisfy the third condition, right? Because k and l, they are consecutive, and then if both of them is greater than k, right, and then we also satisfy the third condition. That's why we can simply use the first one and the third one to check if we can return yes for our answer. Okay, cool. Now we have figured out all the logic, and the rest is just like implementation, right? So let's go back to the problem. So we have a t, and then we have an n, and we have a k, right? Okay, cool. So as long as we have figured out all the conditions, the implementation is pretty straightforward. So so we have, like I said, we have n, k, and an a max n, right? So what is the max of a here? So yeah, basically 10 to the power of 5, right? So okay, cool. So now let's try to read in the data, right? We have k here. Then for int I, starting from 0, I smaller than n, I plus plus, a I, right? So that's how we read the data. And yeah, so I think we have let's check some like corner case. Let's see if n is equal to 1, right? So if that's the case, we can simply do a seek. We only need to check if this number is a k or not. Okay, right? So I can just do like a ternary operation here. So if a0 equals to k, right? If it is, I return yes, else no, right? And then I do a and l here, okay, and then I simply return. Okay, so that's going to be the n is equal to 1 case. And the second one is and then we start checking the rest. So first I'm going to define a flag, right? So this flag means this check, indicates, right, if k exists in array, right? So let's populate that flag first. So if I starting from 0 and I smaller than n and I plus plus, okay. So if ai, right, is equal to k, right, I do a flag equals to 1, and then I break. Okay. Okay, so and let's do this, right? So if first we check if the flag equal to 0, right, then we know, okay, so we can simply return no in this case, right? And then I also return. I can return here, right? Else let's check, right? Let's check if there's any consecutive three numbers that can at least 2 of them is greater than k, right? So else we check this. Check for int I is equal to 0 and I is smaller than n here and I plus plus. Okay. Okay. So here, I'm doing this kind of int count here equal to 0, right? for int j equals 0 and j is smaller than 3, and then j plus plus. Okay. So if I plus j, okay, if I plus j is smaller than n, right, and a I plus j is either equal or greater than k, I do a c, I count plus plus. Yeah, so I do this check because, you know, since I didn't limit the end index for I here, so it could be in the end, could be at the end of this one. That's why I'm adding uh, like a condition here. Actually, maybe this one is not necessary because, you know, since when we initiate this a array here, you know, we do a +5 here, you know, so which means that, you know, if we reach the end of the this a here, you know, we could uh, have reached the some uninitiated number here, you know. I think, yeah, I think we still need to do this one, otherwise we might have some unexpected result here. Okay, anyway, and then after this for loop here, right, so we simply check. So if this count, right, is either equal or greater than 2 here, right, then I just do I return yes in this case, because we know we can always meet the update, change everything into that k here, and then I return here. Okay, and if none of them can give us the this number, this count here, right, so, and in the end I do a no here, right. So this one, yep, that's it, right. Basically, for we check for each of the index, right, we check each of the index here, we check the next 3 numbers here, and we check if there's any 3 consecutive numbers that can have this if 2 of them is either equal or greater than k. Okay, plus we have already making sure we have already make sure that, you know, the flag we is 1, right, which means the k already exists, and then plus this one, then we can return yes. Yep, I think that's it. So let's run the test case here. Copy here. So we have no, yes, yes, no, yes, right? So we have no, yes, yes, no, yes. Yep, so which is correct, I believe. Yep, I think that's it for this problem. You know, it's very interesting problem. You know, you just have to be able to observe this kind of a few patterns. And then other than that, it's just like a simple implementations, right? And of course, time complexity is it's like O of n, right? Because we loop through all the index here, and then for each of the index, we only loop it 3, have another loop with 3 times. So still O of n. Cool. I think I'll just stop here, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.